Hey, welcome everyone, and thanks for joining our DNS Firewall webinar. My name is Leslie, and I'm an account manager at Malware Patrol. So we can keep to our schedule, let's begin. For sound quality, everyone has been muted. That said, our idea for this webinar is to make it interactive, and we will be demonstrating everything in a live environment. So please use the chat or request to speak functionalities to ask questions at any time. These can be found in the window on the right-hand side of your screen. A little hand, and then the chat icon near the top. Presenting today is Andre Correa, founder of Malware Patrol. He's been in the cybersecurity and IT industries for over 20 years. As someone who learned before interfaces were pretty and apps automated much of our work, he has an affinity for the old school ways, the basics of security, hence today's webinar. Andre started Malware Patrol about 15 years ago as a way to share malicious links with fellow security enthusiasts. This eventually became a platform that hosted paid and free block lists for the security community. Today, Malware Patrol has a wide variety of commercial data feeds and packages, including DNS Firewall, phishing, malware samples, C2s, DGAs, newly registered domains correlated with indicators of compromise, real-time DDoS attacks, and more. We offer free evaluations of our commercial feeds. You can visit our website to learn more. And now, Andre will take it from here.
Oh, thank you, Leslie. Thank you all for attending. And it's really nice to talk about DNS RPZ as it's a very effective tool to prevent infections and data exfiltration and some other threats. So first of all, I want to make a distinction between what is DNS RPZ and DNS Firewall. In fact, they are exactly the same. So what we're talking is about the DNS mechanism called response policy zones, in which you can use DNS zones to block access to certain domains instead of the DNS replying with the IP address of that fully qualified domain name. It replies with a different address or with a non-existent response. So there are different policies that you can apply, but in the end of the day, the idea is that you use DNS to prevent your devices, your employees, your customers, your servers from reaching malicious destinations on the internet. So it was first implemented by ISC on Bind version 9.8 and later, and it was also implemented by other products more recently. So DNS Firewall and DNS RPZ are synonyms. So there is another distinction that I want to make, which is what is DNS Firewall, because there are two different offers in the market naming themselves as DNS Firewall. So what we are talking here is the DNS mechanism to protect customers' devices, computers from malicious activities. So using the DNS as a mechanism of protection. Whereas some companies are calling DNS Firewall the service they provide to protect the DNS infrastructure, so to protect the DNS servers, for example, from DDoS attacks, right? So that's the distinction. We are talking about DNS as a mechanism of protection, not protecting DNS from other threats. So why a DNS firewall, right? And the answer for that is simple. Every connection, every time we try to reach out a mission critical application, a website, every time we use an app, every time we use a browser or an email client, pretty much everything we do, we are pointing to names on the internet. We're pointing to fully qualified domain names. And those names have to be resolved to IP addresses. And that's basically what DNS does. So as much as we use DNS for good purposes, malware uses DNS as well. And it usually uses DNS to try to reach command and control servers, for example, or to reach pages that's going to receive like stolen credentials, relay stolen credentials, or even infrastructure used to control botnets. Also, phishing is using DNS very frequently, right? It wants to lure victims into believing they're going to the right website, whereas sometimes these are just domains that are very similar to the legitimate ones, but are fake domains. So using a DNS firewall, preventing access to this malicious infrastructure, you can easily block the traffic. You can monitor the traffic and redirect it to a safe place. So the safe places, we usually call them walled gardens, which is a web page or a website specifically designed to be educational and to show your customers or employees why the traffic was denied, right? So that's what makes a DNS firewall really an absolute essential tool for your network protection. So real fast here, going over what happens to a infected computer when it's not in an infrastructure that uses a DNS firewall. So this workstation here is infected, and the malware wants to reach the command and control server, perhaps to relay stolen credentials. So the computer goes to its DNS server, the DNS that was configured on the TCP/IP configurations, and it goes there, resolves the name, and then reaches out to the criminal infrastructure. When you have a DNS firewall installed in your network or offering this to your customers, the same infected computer would go to your DNS server, try to resolve the same malicious domain, and because your server it would be in constant communication with a RPZ service provider like Malware Patrol and some others in the market, your DNS server would know that such domain is malicious, and instead of replying with the IP address of the criminal, it would reply with the IP address of a educational website or a walled garden. So there are statistics that show the majority of malware is using DNS services on their attacks. Approximately 91% of all the malware samples analyzed were using DNS one way or another. So this is a very effective tool to block malware threats. So pros and cons of using a DNS firewall, there are much more pros than cons. Basically, the RPZ mechanism of exchanging data, exchanging zones, is really a configure and forget one. So once it's configured, and I'm going to show it's really simple to configure it, you just let it work and it will automatically transfer data to your DNS server. So you will be adapting to this evolving landscape of threats as your data provider will be pushing new data about recent threats, right? So protection against attacks, and also the chance for you to use the logs of your local DNS server or servers to locate infected devices. So if you see a workstation querying for a certain domain that is malicious, and this workstation was directed to a walled garden, you can look into the DNS logs or the walled garden web server logs and figure out that that workstation is most likely compromised. So you can take actions. That information can go to your incident response team and so forth. And these logs can be all integrated into your SIEM or whatever log ingestion mechanism you have. So blocking connections to download malware, to accessing command and control servers. So you are protecting and mitigating at the source. But that's also one of the cons, because DNS is so basic, is so into the infrastructure. When you block access to entire domains, that can be a little bit tricky. Some of those domains may be legitimate domains that were just infected with like a single file or a few pages, and you're doing this in a global level for that domain. So that makes the task of finding the right data even more important, because you want data that is really dependable, data that you can trust, that is really just pointing to the threats that are important to your company, and not just pointing to stuff that may not be that interesting or may even cause trouble for you, right? So in case of the popular websites they're hosting, for example, malware, there was a name or a term coined for that is reputation jacking. So they're using the reputation of that company or website to host malicious content, and people usually say there can be any malware, for example, in that domain. There's not possible, but in fact it is. Many big domains are hosting malware, unfortunately, uploaded by their users. So there is also an interesting consideration. In the market, there are some offers for you to point your DNS, the DNS of your computers, workstations, and devices to these services. They're just like numbers. So DNS, just like numbers, easy to remember. And they supposedly would do all the protection for you. And I'm going to tell you that this is not really the best solution. The best solution is that you have your own DNS servers and you choose the data providers, the RPZ data zone providers that make sense to your business for a few reasons. And one of the reasons, for example, is privacy. So any communication your computers do to systems and will use DNS to resolve. Any communications use DNS. So when you're sending this information to a third party, you are really sending sensitive information that can have privacy concerns involved, right? The second is the data selection. And so many of these services just say they protect you from everything, but they don't say exactly what everything is or how the data is sourced and monitored and vetted, and you also don't have the chance to choose what do you want to filter and not. So having the possibility to select the data is very important, as much as the control you have over it. So being able to create your own walled garden, your own educational website is really important, as well as being able to use the logs that are produced by the DNS servers and the walled garden for incident response and also for monitoring in general. It's very important. You don't want to give away all this information, right? So the name of our presentation today is 5 Easy Steps to Configure a DNS Firewall. We're going to go through the steps, which real quick are install a DNS server. I'm going to show that. It's really, really simple. Then choose a data provider. That's a very important thing to do. Then configure the server, how to configure it to use the data from this provider. Then configure your workstations, and then you are protected. So let's go install DNS servers. So we at Malware Patrol, we advise you to have multiple servers, sure, so you have better performance and redundancy. Bind is our choice, although there are other DNS resolvers that provide the RPZ functionality like Power DNS and not. There are also options out there for appliances that you can use. So there's no shortage of options, but we really advocate for Bind because it was the first one to implement, and it's maintained by ISC, right? So let's go straight to the server and show the installation. So I'm going to share my screen here. Okay, a Debian that was just installed, right? And it is a Debian in one cloud provider. So you could have this as a virtual machine in your network or a real hardware in your network. But it's just the latest Debian, and we always have to update our operating systems before starting to do anything. So you would do apt-get update. This one is probably updated. So let's see if there are any upgrades to do. Yeah, it's really updated and upgraded. So we need to install two things here. First, we need to install with apt-get again. Apt-get install DNS utils. So this will give us things like dig and some other tools that we can use to debug if we need. And then we're going to apt-get install bind9. Again, so installing bind9 and some other files. So everything installed, we should have a directory etc bind 9 here. That's great, and most likely bind running or named running. Oh, not yet. Okay. So that's the installation, really. You're just done now, all right? So what you have to do now is configure it according to your service provider. So let's get back to the slides. And I can show you how to do that. Okay. Okay, thank you, Leslie. So the second step is to choose a data provider. And as I said, this is one of the most important tasks because you want to know that the data provider is properly sourcing the data, it's properly monitoring the data, and vetting the data. It's also very important to have granularity, right? So you want to be able to pick and choose what you're going to be protected from. You don't want to overload your servers with many zones that are like related to things that have no sense as threat vectors to your organization, but you also don't want to miss stuff. So having granularity is very important. Data sourcing, a good data source, as well as features like filtering or whitelisting, and the possibility to customize the walled garden. So Malware Patrol has a portal, and we provide these zones. So we provide a zone for malware, a zone with domains that are hosting the crypto mining scripts, also a new zone that is for phishing websites, as well as GGAs, so any domain generated via this malware algorithms for the previous day, the current day, and the next day. So we cover all geographies, all time zones, and also the C2s. So we have these 5 zones you can pick and choose whatever you want to use. As you can see at the left side here, we have a little screenshot of our portal, and what it has is just the instructions of how to configure, install and configure bind. It's exactly what I'm going through here. So when you log into your portal, you're going to see those instructions. And the first instruction, actually the first step, is what you can see at the bottom right, which is you have to tell us the IP address of your server or servers, so we allow our servers to do the zone transfers, right? Zone transfers are not allowed by default, so we need your IP address, so our servers will allow zone transfers. And that's all you have to do. You log into the portal, you put the IP address or addresses of your servers, and that's it. Everything's going to be synchronized. So going ahead and saying, hey, you chose Malware Patrol. Now let's configure bind to use the zones. And configuring bind is really simple. We're going to have to change 2 files. So let's get back to my window here, my server, my live server. Okay, so what we have to do is the zones that we're going to be exchanging here are slave zones. So you have to create a directory called slave, so the zones will be there. And let's change ownership for to bind. So now we have the new directory there. And the next thing is let's edit the named.conf.options file. So here's where you have the policy, as you can see, the options, the options section here. And what we're going to do is we're going to add a response policy here. Let me copy and paste so it's faster. As you can see, I created a response policy for each of the zones that we have at Malware Patrol. So the C2s, GGAs, fish, malware, and crypto mining. One interesting thing here is that you can also attach a local policy. So for example, let's suppose for the GGAs, you want to return the canonical name of your walled garden instead of using ours, right? So you could do here, I'm supposing, for example, you want to use walled garden at isc.org, for example, right? So that's really simple. You could choose one or more zones. I'm putting the 5 zones here, but you could be just protecting from fish, for example, if you wanted. I'll also allow our other server, which was going to be used as a client for this presentation. So I'm going to allow the client to query our DNS, right? So that's cool. That's what we had to do on the options file. And then we have the local, etc bind9 named.conf.local. On this one, what we're going to do is we're going to give information about each of the zones we put in the options file. So let me paste one of the zones here. So this is the C2 zone. We're telling bind that it's a slave. We're telling bind who the masters are, and in this case, the 2 IP addresses are Malware Patrol DNS servers. Where it should save which file should hold the zones. So it's in the slave directory, and it's not going to allow any transfers from here. So the transfers are denied. I'm going to paste the same for all the other 4 zones rather. So exactly the same structure, right? The zone name, the type, who are the masters, the file, and not allowing transfers. So once I save this, I am ready to start bind. Okay, so bind should be running as it is. You can see the named here. So bind is running, and if I go to the slave directory, I should have files. So you can see that the zones were already transferred from our server to this server, which is supposedly your server, right? And the zones contain data. So if you see the GGA zone, for example, it's going to be all truncated because it's the way it stores, but you can see the data is here, right? Okay, cool. So we're good. Let's go back to the presentation. All right, so let's go back. Okay, we chose and we configured, then we can reconfigure the network devices, right? So reconfiguring network devices is just pointing then to the new server that we just installed, right? So let me go to my client here, and I will show you real quick how to do that. Okay, so this is again Linux. It's another Debian. Let's just update it, upgrade it. It should be all done. And as you can see in the etc resolve.conf file, we have the name servers that came from the hosting provider. What we want to do is, instead of using those name servers, we want to use our own name server, which we just installed. So let me get the IP address of the name server here. I don't remember it. All right, here it is. So now this computer is pointing to our DNS server, meaning we can do queries. We can do malwarepatrol.net. It's going to resolve results, right? But the cool thing is that we can check if the zones that were imported, the RPZ zones, are really in use, because we created some names that you can use to test. So if you do dig, let me get it here, dig GGAs, or let me do malware underscore RPZ.test is a name that we created, a FQDA we created. You can see that it points to malware underscore RPZ.test.rpz.malwarepatrol.net. And that's our walled garden, right? So this is pointing to our walled garden. You may remember that we put a policy for GGAs pointing to wg.isc.org. So if you query for GGAs underscore RPZ.test, you're going to see that it's returning a CNAME to wg.isc.org. So you can test all the zones this way. The one for phishing, I believe is phishing. Yeah, exactly, it's phishing. So each zone has this name you can use to test. So this computer is now protected because any queries will be evaluated against the zones that were transferred. And if it's a malicious domain or full qualified domain name, it's going to be pointed to the walled garden. Okay, so going back to the. Thank you, Leslie. Okay, so we have it configured. We have the network devices reconfigured. You would do similar configurations if it was a Windows or a router or some other devices, right? This is an example of a walled garden. So you would be showing your customers, hey, your access was denied because it was, you were pointing to malware, right? So the more informative, more educational you can be, the better. And therefore you have your customers protected. So protected 24/7 round the clock, because the zones are incrementally sent from our DNS servers to your DNS servers. Any changes we made, and we made changes multiple times per hour, are passed to your servers through the XFR mechanism. So to finish here, what are the key takeaways from this presentation? Very important one is that a DNS firewall is proactive protection between evolving threats. So different threats that are evolving. If you get a good service provider, you're going to have good protection. And it evolves seamlessly and really configure and forget. So choosing the right data is really essential. So your DNS firewall will be just as good as the data that is powering it. And it's a configure and forget, so it's really simple. As you saw, you can just get your DNS up and running in just a few minutes and protect your network. So it's a very simple and effective way. And that's all I had. So if we have time, let's go to questions. Leslie?
Okay, thanks, Andre. We do have a question from a participant. It is, what can a DNS firewall do regarding ransomware infections?
Okay, that's a good one, because the DNS firewall is very effective. Is very effective against ransomware, because most of the ransomware requires contacting the command and control server to exchange encryption keys so they can encrypt the hard drive and therefore ask for a ransom, right? So many of them, if they can't reach command and control server and exchange this encryption keys, they don't have encryption keys to encrypt, so they don't do anything. So DNS firewall, if you have a good coverage over pretty much GGAs, so the more families we have, the better, and you have coverage for multiple days, so you're not caught in trouble with like different time zones, then you're going to have a good protection. Sure, the first thing you want to do is to not get infected, but if you got infected, disallowing access to exchange encryption keys is very effective, and it's a very, very good line of defense against ransomware.
Okay, thanks. Looks like that's all the time we have today. We're running just on time, or a minute or two over. So just to reiterate, we are going to send out an email with a recap of the presentation today, along with some additional helpful resources that we've gathered. And you'll also receive a replay link to the webinar. If you have any questions, please email either one of us or use the contact form on our website on the contact tab, or using the menu to get to that. And that's it. We thank you all for being here with us today, and have a great afternoon.